do something unintended. So the proposal, part of the proposal is to not.
So basically the behavior you are seeing today is like if you have complex enough application, then the shutdown is prone to either crashes or deadlocks.
Okay.
Right? And basically, like if you any larger app, like say Visual Studio, they basically have to go out of their way to make sure that there are no finalizers running during shutdown, because if they do, they get these crashes or deadlocks, right?
So in the past, we kind of tried to write finalizers. Well, in V1, we designed this feature because we wanted to run them at all costs. And the reason for it was there were many resources that were super scarce. Like you could run out of, there were like on Windows 95, there were like 64 handles for files or something. I now don't remember. Now it seems like almost all resources that we guard, they are not, like we still have finalizers, but it's more of a performance optimization. It's not like there's a limit on, low limit on number of handles in NT, correct?
That's true, but what the finalizers do today, like outside the shutdown, right? They basically make sure that you don't have a native resource leaks.
No. I understand that. Like if the process is not shutting down, we need to run finalizers because that's what they are for. I'm saying in the past, even when the process was shutting down, we would try to run finalizers because we wanted to close some of the system-wide resources like handles that may not be closed immediately, correct?
I don't think so. Like I think even on Windows 95, when you shut down the process, like whatever files you had open, you always took care of
really?
It up, right?
I thought, why were we even running them ever?
It could be persistent state involved.
Yeah, like I think it's one thing is persistent state, and the other thing is it was the design in early Java, and I think we just like said, okay, like sounds reasonable. We should do the same thing, right?
I thought there was something about like, there are some, so even today there are some resources, like for example, socket ports. Even if the process exits, the socket will be alive for some, the port will be kind of considered open for some time, and then you make another process make a problem reopening it. I thought that like in the past we had a lot of those.
Right,
could persist after
those
process
things
shutdown.
still exist, right? It's like the classic sockets, database connections. If you kind of terminate, right, the system then be designed to clean up and recover eventually, but it might take a while. Right?
And I'm asking because I like the idea of basically, like you said in the, I was reading this, thread, and you said, well, maybe we should just fix it in the runtime, correct? And like not run finalizers at shutdown. But I wonder whether we care about some of these resources that still may be worth finalizing because they persist.
Right, and for those, we will let people, hey, register the explicit shutdown route that we will get to.
Basically, we would have two different finalizers. We would have the ones that do run at shutdown and those that don't.
No, basically we would basically say if there is something you want to run at shutdown, there is alternative way to do it that just for the shutdown.
I see. You hook up to shutdown event and then you do it manually. That doesn't help. Yeah.
Finalizers, you can run them while the object's being used concurrently with any of the other objects mixed up. And once the finalizer runs, we can't use the object anymore. So we can't just arbitrarily run finalizers. That seems to be the problem right now. Whereas this unload event, you can run that code agnostic of what it's up to the user what they want to do there. But
I mean, one kind of issue with hooking up to the event is you can start executing arbitrary code, and if you don't know how to write it, you run into yet another set of problems that we already solved with safe handles. Like basically we had the problem that people would run, crappy code in finalizers. So then we created safe handles to solve the problem, which is like, it's almost declarative. We will just run it for you, and we know that we can. If we hook up an event, people can, like, I don't know, write to the console, like, do whatever they want.
Which I'm sure some people will do.
So maybe, like, I wonder whether kind of the dual finalizer approach would not be even more reasonable. Like, basically have some.
Well, we did have the dual finalizers, like we implemented the critical finalizers that are kind of,
Oh, yeah, I remember something.
yeah, but we kind of, I'm not sure, but better than talking about.
Right.
How does safe handle work? I mean, how does it guarantee that?
Basically, what safe handle is, it's like handle to native resources with the ref count. And the problem it's solving is that when multiple people are accessing that native resource, the ref count is always incremented, and it's like interlock, let's say ref count, right? And then whenever the ref count drops to 0, the unmanaged resource is free.
But also, in addition, it's not only the ref count. To me, the main value is that the finalizer of safe handle is simple. It just calls close handle. There's no complicated code. So it just does one invoke to close handle. And safe handles has one field that is the handle. That's it. So it's reliable.
No, safe handles don't have just one field that's the handle. They do have the ref count.
Okay, yeah. I'm saying, like, there's no other things that it disposes.
There's no object wrap.
Finalizers, correct? There's not like complicated code. It's just, it stores the handle, calls close handle when it needs to. Which is much more reliable than having open-ended, or open-coded, finalize method.
But these handles are still things that the OS will take care of if the process is to just crash or something.
Most of them.
Yeah, most of them. But that's what I was started with. Like, I still think there are few resources. Most process shutdown will just clean. There are few that, it won't. And I would like to have a solution. If we go with the route of, okay, runtime doesn't run any finalizers as shutdown, what is the solution for these resources that should be cleaned up at shutdown? And one proposal is, like, just let people open code some, shutdown started event. The thing is, if they are not careful and they don't code it correctly, they can be, back to the original issue that we tried to solve with safe handles.
How does this compare with full framework, by the way? I mean, this is only core CLR and core T, I guess.
On full framework, you have updomain unlocked event. That's basically what people are doing today.
Yeah. But as far as the finalizer semantics go, like, they are different from what we would do then for core CLR and core T, correct?
So what we do on desktop today, right? We try to run the finalizers, and because of, if there are crashes, yeah, sure, you crash, you kind of don't run all of them. If there are deadlocks, we have like 40-second limit on, okay, if it doesn't, if everything didn't finalize in 40 seconds, then there was a deadlock, and so we shut down it. And we actually run into the same thing in core CLR. So in core CLR, we got rid of the arbitrary timer. So it actually happened like in ad hoc way, because of, like, the timeout was causing problem on like phones, because of the phones can be super slow,
Why don't we don't run the normal finalizers, but run the critical ones?
We could, but that would mean we need to bring back the critical finalizers to .NET Core.
I see. Okay. Or could we basically special case it? Just safe handle. Like, do we have safe handle in correct?
Yeah, we do.
special case safe handle. We only run the safe handle finalizers. So if you have one of those resources like a socket or something, you just store it in a safe handle, and that's the way to run it at shutdown. Otherwise, it doesn't run at shutdown.
Can you make a safe handle for anything you want?
Pretty much.
It basically has to be Windows handle, and has to have a closed handle. Closed handle has to work for it.
Does it? I thought you can override that.
I'm not sure.
I think we have special derivatives that indicate what constitutes the handle to be valid or invalid. But I think the idea is you can still override it and call another method. I think the default is close handle. But I think we can
But
have.
you are right that we can do that. The problem with that is so the fundamental flaw with the safe handlers is that you kind of cannot do anything intrinsic in that, right?
Correct.
Stuff like the other safe handlers could have been already finalized, right? But
Correct, but it just takes this handle and calls close handle on it. Like you shouldn't actually be. The point of safe handle is you shouldn't be doing other states.
well, that's another like it's like what people want to do in the shutdown events is like say write telemetry, right? Closing database collection is also not like it's like close some OS handle. It's kind of okay, send this like bunch of bytes to the socket and to make the SQL server happy and
And if they were to be able to override that safe handle and do whatever they want in it, we still have the same problem.
Yeah, I would not. If we had this feature, and we probably had because we had like a hierarchy of this safe handle. I would just have like one safe handle. You cannot do anything with it. You just pass it, an in pointer, and it calls close handle on it. That's it. If you have more complexity, maybe you hook up to the the event that you mentioned.
I mean, I think your example with telemetry is a good one because people probably misuse finalizers today to do exactly these kind of things, right? So this is not a cleanup per se. It's just this is code I always want to run, right? And then and then they use finalizers to represent those semantics. But for resource cleanup, I think safe finalizers is just one example. I mean, other examples may be freeing memory or whatever, right? Or like resetting global state that you can't rely on Windows.
Memory, that doesn't persist after processing.
No, sure. That's what I'm saying. I mean, if you generalize resources, you could imagine like a shared, let's say a mutex that you have to release, right? Like if your process dies, maybe Windows does it for you. But there's probably some cases where Windows can clean up the thing for you.
That's why I asked.
But I don't think safe
safe
handle is the only example of that because that's literally just
that's what he's saying. It's like that people would have to wrap all these guys in safe handle.
No, but the question is whether you can.
Maybe some of them are not represented. Some of these resources are not represented by handles.
Yeah.
But I would say, give me an example of those, because the only one that I know today that has this problem is sockets.
Let's say you want to delete a file, or you want to.
Let's say the semantics is.
Oh, you mean you want to delete a file when you yeah?
Or you want to write something to a stream before closing it.
Yeah. Pending rights.
Maybe. I think you can kind of, many of these scenarios, I'm not saying that the solution is perfect, but many of these scenarios you can, next time when you start and you discover the file, you clean up, or, like, there are some solutions to it. The sockets, there's literally, I don't know about the solution. Like, if you don't close the socket handle, and, your process dies, doesn't close the handle, you restart,
the same thing.
You may have problems. There's a way to open, sockets such that you don't have the problem. In a lot of cases, your process restarts, open automatically, and now cannot open the same.
Well, let's go back to the original one. You're not saying you don't run finalizers or shutdown, right? All you're saying is you do a best effort, right?
No, that's what we do currently. The proposal is to not run finalizers.
To not run them at all.
At shutdown. Normally, when GC runs,
Especially on
Nice.
objects, which is just illegal.
By the way, like in Java, they had the same problem, and what they did exactly what we are proposing here. Like years ago, basically they said, okay, running finalizers on shutdown is like just prone to these deadlocks or crashes. So just stop doing that, and just if somebody wants to clean up and shut down, please shut down. Like I'm not seeing that.
Yeah,
That means
I don't know.
bas-
I mean, you have much more context here. To me, the shutdown event also is not super convenient for libraries, because let's say I have a library that uses sockets. I kind of, I cannot ensure that I will stay reliable in the light of process shutting down and restarting, because I don't own.
But
the
shouldn't be
application.
this like closing all the sockets kind of the hard way, whatever, to be the responsibility of the sockets library?
Should it be a responsibility? Well, I'm saying, like, let's say the process shuts down. My code is not, like executing the library code. Like, who will close the socket?
that's what he's saying. I mean, it's a responsibility of whoever used the library to call the right methods before the handle.
No, it's the other way around. It's like it's like it's the same thing as if you have
Well,
like
then-
database provider, right? It's like you don't want kind of every user of the database provider to say, okay, there is this like special thing to kind of.
But that's exactly what I'm saying. Finalizer, like a safe handle. I'm using sockets. I would store the handles in safe handle, and then the runtime takes care of it if the process shuts down and my code is not running.
So you have all I'm saying is that instead of like an event, you would like to have like some special type of object that has like special type of finalizer that still runs.
But how would that run then? Then I'm confused. How would you write that finalizer if we say we're not running that on shutdown?
Well, no, it's like instead of like having event, right, the runtime would have condition if the type of object is like special
I
safe
see.
handle that runs on shutdown,
I see.
then you will run it. All other finalizers, we just like skip.
Oh yeah, so you basically
Yeah, that
say
makes sense.
agreeing
Yeah.
with me, correct?
Yeah, that makes
Yeah, I'm
Yeah.
saying that it's alternative, right?
Yeah.
And then we can kind of, I'm not sure which one is kind of better. I think like kind of, specializing how finalizers run for one particular type of object, that's kind of odd.
It's a bit odd, but the event handler, if it's a reusable library, what it would have to do is every single handle that it hands out, like it would need to record in some table. Then it would have to have some policy for pruning the table, and like finalizer.
No, the policy for the pruning the table, it's simpler. It's just like when the finalizer for the handle runs, you just remove it from the table. Right?
Oh, if we have finalizers, sure. I'm saying if we didn't have finalizers that run at shutdown.
No, it would be like
No.
the finalizer, so
Oh,
the
I see, the
constructor would add
finalizer.
it to some
Yeah,
list.
I see.
The finalizer
Yeah,
would remove
yeah,
it, and
yeah.
anything
Okay,
that's left would
I
remove.
agree. It's
Um,
still you would have to have a table and you have to track basically every single.
And there would have to be weak reference
Yeah,
table.
yeah.
I think the problem with having a special kind of type with the finalizer is that object itself will have undefined state by the time the finalizer runs, if it's not dead already.
Say it again.
So they would have to write the finalizer code such that.
You mean the event
some-
code? The event code?
No, I'm talking about if we have a special type object
Oh,
with
yeah,
finalizer.
yeah.
They would have to treat the finalizer code differently from the normal finalizer.
Yeah.
And write it as though it's similar to the event handler code. They can't make any assumptions about the state of the object.
Yeah.
It'll be awkward.
In fact, the event handler itself, you don't know what's the state of the.
Yeah.
Yeah, but it's
But-
like
but you
it's,
can
the,
write
these
it in a
event
way that-
handlers are for write by rocket scientists, right? It's like you kind of don't want like every random guy
Yeah.
who writes finalizers to write one of these. Right?
Yeah, so everybody who writes something with sockets.
No, I think it should be responsibility if there is this problem with sockets. It should be responsibility of the socket library to clean up properly during shutdown or try to clean up properly during shutdown. Right?
Is it fair to say that reliably you can really only call basically native code, right? Because if you say you can't really run the object, I mean, if you take like the file delete API, I wouldn't really be able to use our APIs, for example, to do
No,
the file.
you should be able to, right? That's the point. Today, in finalizers, you cannot, because of you cannot know what other parts shut down, right? For example, you cannot kind of call console write line in finalizer. So maybe console was already finalized, right?
Yeah.
But if you say, okay, like during this unload event, like everything is still up and running, only those parts that require special shutdown, right, are the ones that can be cleaned up, right?
No, you're not talking about the case where I've subscribed to the event, right? I mean, what you just said is if we have the special object, the code that I can run there is very limited what it can do. And I'm saying in that code, I probably can use our APIs, right? So if I wanted, for example, if I want to have the semantics that, I need to clean up some files, right? And I want to make sure this runs during shutdown. So I derive from the special object. In that method, I probably can't use our file system APIs to delete the file, right? Because they may already have done something similar, right?
Well, they made it.
Yeah, you could in the sense. So I was planning on raising the event before things actually start to clean up. Like, for instance, console wouldn't be finalized now because it would still be alive, and we're not running finalizers on shutdown. So you could still use it.
I see what you're saying. Because we don't run finalizers, you actually have more objects that are likely to be not in the dead state, essentially.
Yeah, you basically think about it as at the end of the method, you basically just, there's like implicit call to this like,
That makes sense.
Now, right?
Yeah, that wouldn't be bad. I think that would be doable.
Well, but we still have to have those finalizers. I see. So libraries would still have to have a table and would have to track handles that they hand out.
If these are the special handles that absolutely require.
Yeah, it's not great.
Well, why would we have that if we would have that special object? Why would you not just derive from that guy? Because then the table is maintained for
Which special object?
that conceivable object that would make sure it will always run.
You mean critical finalizer?
Yeah.
Well, if we have it, I don't have a problem with it.
That's what I'm saying. So I mean, that seems not like a bad.
If we do both,
Right.
basically we do an event for deleting files and whatnot. We run it
Telemetry and whatever.
before we even do anything.
Yep.
And then we just run those critical finalizers, and they have to. We may even not call them final. I don't know what we want to call them. We create a type, a safe handle that just calls close handle.
So the problem with the critical finalizers is, so are you saying we should be able to do anything, like to extend that, or it's just for handles?
It's basically just cross handle. I think it would solve the problems that I know about. I mean, you're not saying maybe there are more, but I'm just saying.
It wouldn't solve like the file delete scenario.
No. Well, but file delete, you just look up an event.
Well, you would have to do
Some people
both,
have
right?
the event
Technically,
and some
because-
depending on what your semantics are. But yeah.
Because file is not like libraries. Maybe libraries create files, but
So by the way, the event you propose is assembly load context dot unload, correct?
Mhm.
Is this API available on desktop? My understanding is we didn't port assembly load context to desktop. So on desktop, I would have to do something differently, correct? I would have to subscribe to app domain, unload, whatever. Yeah, that's the thing I don't like, honestly, for libraries now, because that means that writing.
But there is strong desire to create compat open thing for assembly load context for desktop.
There is or there's not.
There is strong desire to do it.
Yeah, okay. Then in that case, if there's a single API I can use across all our runtimes and can subscribe to the shutdown, essentially, that's fine. But if I were now to say, oh, you want to subscribe to shutdown, well, now you have to know what you're running. That seems
One of my fears of this
unfortunate.
is we're taking code which in many cases would have nominally been run from a using statement
Mm-hmm.
and moving it to this API. So the equivalent app domain, like process exit or process unload, all of the app domain handlers, that is the #1 source of problems in our unit test framework right now. because the BCL has bugs that cause it to throw exceptions. Like WPF has bugs, BCL has bugs, and they all hook onto app domain unload, and they all throw exceptions, and they take down our unit test process, and there is literally zero recourse for us. We have dramatically changed the way our tests run to avoid BCL bugs because we can't stop it from crashing.
Why do you
And this is just
wrap the calls
what call?
in? So it crashes. You find out which call.
Which call crashes? It's app domain. The event that is raised when an app domain is unloaded via process exit or explicit unload throws an exception
Oh, but why does it throw the exception?
because they're bugs.
No, bugs in what?
The BCL and WPF.
Why is this event calling WPF?
Because WPF responds to app domain unload.
So it wants to do
they
the kind of,
themselves hooked up to. Okay.
so
I
they are
understand.
one of those libraries that
Yeah,
want
yeah.
to do the explicit.
Yeah, I
and
understand.
When we find bugs in code that happens with using, we can try to catch it and life can move on. But if more people move to this, it'll be more bugs that our code, it's like the tests have run, everything is done complete, like,
Okay, so
and
we could solve
everything
this problem.
crashes.
We could solve this problem by, instead of having an event, having like a way to you basically give your cleanup provider.
well, it doesn't matter so much as it's
But
long.
It's
if
like basically
we call user
the
code,
fundamental problem is that people want to run code during shutdown, right?
Yeah.
And they either subscribe to unload event or they create like finalize object that they finalizable object that they stick into static variable and they finalize the rounds, right?
Yeah, I'm saying like if we basically told them, provide us, provide a callback, we're gonna call it instead of them creating the event handler. Then we can call the provider's spare library, and we can actually catch exceptions and log and keep going.
That's kind of it goes against what we have been. This is kind of the policy that we have in CRV1 where we were catching exceptions that we didn't know where they came from, right? And we found that it doesn't work because of like when you catch exception that you
I'm
don't
saying
know.
the user code can do whatever they want. Their unit test framework would actually use the event and just execute all those handlers. They can catch or they cannot catch, whatever they want to do.
Okay, and
It's-
if they catch
it's not
and
me.
instead then they get deadlocked, then how would it? Basically, there is a bug basically in the shutdown to handle the
Then
handling,
they,
right?
there's a deadlock, they just don't run this handler. The callback. I don't know. I'm just, I'm not saying that it's a, well thought through. I'm just almost brainstorming what to do with it, but.
Isn't it good that it crashes the process? It'd be easier to.
So here's the problem, like we literally have wasted weeks on BCL bugs that we can't fix.
Why
We've,
can't
like,
you fix?
Emailed we've had to talk to the XUnit maintainer, how can I fix the fact that when WPF shuts down, it decides it's hilarious to go through and query Windows handles without try catching stuff? I can't fix that. All I can use is insert a DLL that handles app domain unload earlier, reflects into WPF and clears all their tables for them so that they won't screw me.
Well, did you let the WPF team know?
Yeah, we let them know, but like we'll get a fix in 5 years, So it's very.
And if you find it in BCL, let us know.
We filed the bug and we'll get that fixed in 2 years.
In BCL?
Yeah.
No.
On full framework?
About 2 years from now, we'll get it fixed. So,
But I mean, generally speaking, the question is, to me, the discussion is almost moot because you can never really, like in any sort of orchestration system, if some component throws, there's limited things you can do, right? I mean, in general, the question is it very likely? Do we introduce a design where it's very likely that people will accidentally do the wrong thing, right? And I think that is probably true if you run during shutdown and you have to assume other things already did their cleanup. I mean, that's almost also a given. So the question to me is almost like given that the world is terrible, like what is the least terrible thing we can do in order not to screw with people too much?
But the other thing too is, what do we do if we give her to catch exceptions? How do we report? Do we report it and move on, or do we?
No, like catching exceptions is bad, period, right? Like if you, right, we were on this plan before and it didn't work, right?
The biggest, I mean,
It's a
Java does
fundamental
it
tension.
a
It's
lot
bad
more aggressive.
low-level code. It's a fundamental necessity in application code.
Yes, yes, that's right. But, you know, like,
That's what I was saying. If we change this API such that it's not an event that the runtime executes these things and people hook up, but rather people give you callbacks and then the application code calls them to shut down.
But that would mean that every application code in the world has to subscribe to the event and say, for each handler execute. Which now means, well, what's the likelihood of people screwing with that and not doing that? Well, close to 100%,
Okay,
let's say.
so another modification. By default, we could just call them and then let people override the behavior and catch exceptions for some handlers.
That wouldn't be terrible.
Yeah.
Although at some point the question is how many hooks do you have, because at every layer you can introduce the same mistakes. I mean, at some point it's just, well, you just have to let the process die. I mean, another option is if there's a list of handlers, you could potentially like clean them before.
So if we worry about the time to fix it, well, even if we added this new API now and those handlers that people have to provide, when will WPF provide those instead of hooking up to domain unload?
They actually need to care about domain unload, I think. The specific problem WPF is trying to solve is they subclass a lot of windows. And basically, they subclass a lot of windows with delegate callbacks into managed code. And when an app domain unloads, you're essentially unloading the DLL that backs that WinProc subclassing. And so they're trying to unregister all their WinProcs on the way now. Which I guess if they use assembly load context, I guess.
no, it's like, I think the assemble context is equivalent to app domain unload. It's the exact same thing.
It's the same problems that it has. Yeah.
It does physically, when an assembly load context is unloaded, it does physically unload the DLLs behind it. Well, it's different because it's different because today they use statics to basically partition their handles that they've done. And that gives them basically, when they're unloading, they just walk through their static list and undo things. If with assembly load context, they'd have to partition by assembly load context and handle. Since app domains kind of give them free partitioning because there's a static per app domain. They have to change it a little bit, but today their code is very just ambient, just relies on the ambient app domain. But anyway.
But statics are still local to the assembly, right? So when you unload.
Right, but what he's saying, like, so just to be clear, today the assembly load context isn't kind of unloadable, so we didn't build that feature yet, right?
Right.
And once we find time to build it, like, it won't be the case that, you take like random code out there and it's like supports automatic downloading, especially this kind of fluid, like, the code that does manage native interrupt and so on, right?
So
but what because of the assembly context unloading, like, in the mid-flight isn't built yet. See, the way we would implement this is just like the assembly context unload, just forward to app domain unload. So any problems that app domain unload has today, or could apply it to.
What do you mean forward to app domain unload?
Well, so the app domain unload is still there, so it's kind of the most convenient implementation.
Oh, you mean on desktop once both of them are available, app domain and assembly load context?
So app domain unload, it's compiled into core CLI, it's just not in the public surface.
Oh, okay.
Yeah, it's an interesting thing. I mean, I think Eric should probably take a look at that because I think the semantics are not epic, but at the same time they never were really epic, right? So it's not like we're making it necessarily substantially worse, but it's very hard for me to judge what the impact on the ecosystem will be if that's the new behavior. Like I honestly don't know. It may be that pretty much no other libraries are affected. It may be that some of the libraries are affected and they have a very trivial fix. Some of them may just misuse the feature. But So it's hard for me to make a statement on, what will happen if we do this in .NET Core. On the other hand, though, if you want to change it, I mean, that's the time, right? I mean, once we ship V1, it's much, much harder to change that.
Well, sure. I think.
I mean, you could even go with a state approach
we already
and say,
have this event. Right.
I think that's being added, I believe, right?
And of course you don't want to.
Yeah.
Oh no, yeah. And we just write some guidance. Tell people to be careful.
It just means until we have assembly load context on desktop, there is no port relay to actually do that. You would have to do it. Yeah. I mean, you could still do probably reflection. That would probably still get you far enough. I mean,
just to make sure, in addition, so we would have the event. In addition, we would do the safe handle. I mean, one of those, not extensible, just close handle. Is that the plan?
So one option is we could do it stage, right? We could say for now we don't have it and see what happens. And if we see we need it, we can still add it. I don't know. I mean, it seems, the question is also what's the design of the type? Is it okay to just special case safe handle? Should we need a general purpose type you can derive from? I don't know.
Yeah, general purpose.
Has all the problems that it has.
Like opens the door to start introducing back problems. To me, the value of like having a closed safe handle is that it is safe. You give it an in pointer, it calls close handle. That's all it does. And then you don't have to hook up the events, you don't have to have a table in libraries that want to do close handles, you don't have to like.
They're like, what if you kind of. So one thing it depends on is that. Oh, so we would basically. So we would still need to run kind of the full GC during shutdown.
What if we don't do it with finalizers, but rather just provide an API to register safe handles, and we'll just.
Well, that's exactly that. Right?
Well, except the safe handle itself wouldn't have to track its own instances. It could track all of its instances and handle the unload event to clean them up.
You are saying we would kind of build a weak handle table.
Yeah.
For people.
Just for safe handle, for easy.
By the way, even if you special case safe handle, it doesn't buy you much. I can still derive from it and override dispose and do whatever I want.
No, I'm saying we could add a type where you cannot do it.
Sure, but you're saying like if we just special case safe handle, I'm saying that wouldn't be enough. You would have to introduce a new type that you literally cannot change.
Do we already have a safe handle?
Yes.
I see. So we cannot seal dispose pool?
I don't think we can. Because it's already exposed as virtual. I mean, the other question is like, how much do we care, right? I mean, like, how discoverable would that be, right? Maybe it's okay for the 5 people that really, really need it and really know what they're doing.
Well, it may be 5 people. It may be actually just, like our teams. It doesn't change the fact that.
You can hang yourself, yes.
That if we don't have this feature, we have to keep a table. Each table, we have to manage it, prune it, basically. And therefore, we have to, implement finalizers on these things. And finalizers would have to prune the table and then hook up this event and what's still left clean up in the event handler. That's a lot of ugly and unreliable code.
That's true, but at the same time, like, I mean, it doesn't matter whether the runtime provides it or us, because I mean, I guess the code is more or less morally equivalent, right? So the complexity is more or less there. Like whether you expose it there or there doesn't really.
No, because the runtime, as he said, can special case these handles.
But it's kind of there are like with hard things in the runtime too. One thing it depends on is that today, the ugly part about shutdown is that we run full GC during shutdown just to run these finalizers. Full GC running during shutdown is just like waste of cycles, right? You have kind of, the thing is going to be shut anyway, so why do you want to collect all the garbage? Right?
Yes.
So we would need to still run the full GC, then go through the or finalizable objects that the GC finds. Run the finalizer on the special ones, ignore all the other ones. What if like some of these guys, creates like more of these special finalizable ones? Are we going to run the GC in a loop, right? Like we are doing today? It just makes
no. How could they force more finalize?
They can just like if somebody screws up.
How can they screw up?
Within the close method, they can do new.
No. There's no close method that they can do new.
Well, whatever they do.
If there's a background thread that's constantly allocating these things, and then somebody calls environment.exit, the background thread's still running, creating. So we are now executing shutdown. Do we have background threads running and that can be allocated?
Yeah.
Really?
So today we don't. We basically stop those background threads whenever they are, and they can be in log, they can be holding logs, and if that happens, the shutdown gets stuck, and on course it deadlocks infinitely on the desktop. It times out after 40 seconds.
Yeah, shutdown seems to be hard.
No. Sorry, I think we are talking about two different things. I imagine that we will say we shut down all the threads.
And how you can shut down all the threads?
Well, you said that you shut down all the threads anyway.
Well, the OS does it for me once, like the process is about to be killed, right? But as long as anything in the process is running, the background threads are still there, right?
Don't we do the thread abort thing? The thread abort exception to abort threads?
No, we just like what we do today at shutdown. We just stop the threads whenever they are.
Exactly. So we would still do it.
I don't think the point of this is that that's one of the sources of unreliability. So when you stop the threads whenever they are holding clocks and all sorts of things.
But like, who cares? Because the only code after that we will execute, we will take those safe handles and call close handle on each of those in pointers. That's all we will do. So we don't.
Well, but it's like, what if in your save handle you can, in your close method of your save handle you want to take log to do something?
No, you cannot override the close method. You don't do it. We don't do anything.
But it's like I don't understand. Like the close handle method for your save handle. It's like your user provided code.
No, it's not user provided code. That's what I'm saying. We have a built-in type. The only thing that it does, it calls close handle on the int pointer that is a field.
And what is the close handle? Where does the close handle come from?
From like socket.
And who says that it's like who would? But it would mean it's like the socket library who implements it, right?
The thing what Krista is proposing is assume we have a new type. Ignore safe handle. Let's say we have a new type. The only thing that this type does is it gets a handle.
But then what is that handle?
It's an in pointer.
Okay, in pointer.
Yeah.
Good.
And then say the semantics are OS specific. So on Windows you would always call a close handle.
No, but
that's not right. I mean, I think Jan's point is close handle isn't always the right answer for an arbitrary endpointer.
Right. The close handle is like the right answer for like the 5 handle types on Windows, but on Unix you don't even have the 5 common handle types. Right?
Yeah, so at least sockets we could solve with close handle, correct?
Not on Unix.
So, but it's not even necessarily a handle. Like, what about some native memory that was allocated and the address was stored into a handle? Then you need to go through memory.
Yeah, I'm saying we don't have a problem. I assume we don't have a problem with memory because when the process shuts down, nobody cares about the memory. The OS reclaims the memory that the processor allocated. And it's also not.
My point is that there are many different things beyond just a handle that works with close handle.
And inside, it's the handler, kind of the Magic OS handler, it's like Windows specific concept, right? So Windows is big monolithic OS that like exposed everything as this like opaque handler, right? On Unix, like you don't have this kind of thing. Right?
No, the sockets also have handles.
No, but they're like what I think what Jan is saying is like on Windows you have a hierarchy of handlers, right? And you can close various different kinds of handlers by the same close handler method. Unix doesn't have that. They have special methods for each of those because you can.
And even on Windows, if you want to close like connection to a database, that's not a handler. It's like something like database provider in PTR, right?
I mean, I think let's say we can solve this problem generally, but we could say that if you take our safe handle hierarchy, right? I mean, you could imagine that there's different kinds of safe handle derivatives that basically do the moral equivalent of closed handle for whatever the corresponding handle type is. Is it technically open-ended and arbitrary user code? Yes.
Yeah.
But is this very likely to do as complicated as stuff as general finalizers do today? Probably not. Like if we say there is a general purpose handle for this library, then so be it. Don't that's people misuse that feature. But if you say, look, we have a special case, safe handles and the derivatives, we only run those, and if you fuck up, yeah, you fuck up. But you shouldn't fuck up, and we should. When somebody says, "Oh, you have a socket library," we should tell people, please derive from this type. Do the closing only, like for this particular native resource. Don't try to do arbitrary managed code operations there. Don't do any other crazy shit. Just do that. Would that not go as get us like 99% of the way? Because you probably don't have deadlock issues. You probably don't have, I walk arbitrary object graphs and allocate along the way kind of issues. Like I mean, that would probably get like I don't know. That's very close to where we want to be.
So you're suggesting an object with a finalizer that they can override and do whatever they want?
Well, I mean, as Chris said, we could just say it's a safe handle and all its derivatives.
No, I would even start with it's a safe handle for a socket handle, because honestly, the only resource I can think of where it will be very difficult to deal with shutdown and restart of a process is basically sockets.
No. Database connections are definitely in the category.
Okay. So the database connections.
That's what I'm saying. I honestly think if you make it a general feature, I think it's a bit more resilient to changes. I wouldn't special case
and
too much.
The kind of the special object that runs finalizers, it kind of sounds simple from the outside, but when you look at the runtime consequences of that, they are like super ugly, right?
The problem being that you
basically now the GC basically knows about this like random framework type, right?
No, I buy that. It's just the question is what's better, I guess. Like what has a higher chance of not being unreliable?
I think it's awkward to have an object that has a special kind of finalizer. I think it's hard to understand that difference. A normal object finalizer versus this object finalizer. You have to write them very differently. You have to be very careful about the state of the object.
I agree with you on principle. I would say the difference here is that if you would really use safe handles, it's kind of the guidance we give people today. We say like if you have a native handle, don't write your own finalizer. Just hold on to a safe handle and use that one. If there is no safe handle that you can use, create your own, but isolate it to this type. So it's kind of consistent with what we tell people. But I'm not sure how many people actually follow that today. So but I also don't think many people write finalizers today either. I think that was way more popular when .NET was adopted earlier because they came with a native C++ style attitude and they wanted to have destructors.
So what if this is the infrastructure that this shutdown cleanup stuff is based on, and safe handle is one type that handles the details for you?
You mean implemented on the managed side as the abstraction rather than the runtime side? Right. Yeah, as I said, I wouldn't be fundamentally opposed to that because it is probably ugly code, but as Jan pointed out, I think you just shift the complexity, right? You can either say we purely handle or manage, we maintain our thing, we handle the right events.
Then maybe. So like if I'm a library, I hook up to this event handler and I have a guarantee that we will execute it, then yes. But if people start chaining the event handler and like the first one throws exceptions, like mine is not going to execute. Yeah. So it's kind of...
Well, the process will also crash.
Exactly. So maybe, if we basically make it like per library, it's not an event handler, or it's a chain that we guarantee to execute everyone and every node in the chain, then maybe it's equivalent. Maybe it's a basically managed code equivalent. You have to implement the weak table and all this thing and track with normal finalizers, but I guess a library could do it. We could do it basically in managed code in a second. But I think we would need this API to change slightly such that it's not just an event handler that, first.
No, but
first,
you have the same problem with finalizers today. It's like when finalizer throws, the process it crashes right away. Right? It's like when you have like abnormal exception in there, like.
And same problem with tasks. If you throw an exception in background tasks, they could bring down the process.
I mean, the question is if we would say we use safe handle or something like that, and we maintain our own managed library implementation for guaranteed cleanup, right? The thing that I would be worried about is that if we basically say, okay, there's two kinds of things you want to run during shutdown. Just generally cleanup, that means use safe handle or derivative, right? And then we do it for you. If you want to use telemetry in the application code, you subscribe to this event. If both of these concepts are ending up in the same queue essentially, because they all subscribe to this event, I think you may now have problems because application code is maybe accessing stuff that rely on the safe handle still being valid. So I think what you want is you want to say every customer, normally application code that just wants to do telemetry on shutdown, they should run first. And then all this safe handle stuff should run, basically it's the last thing. Because once they're done, you probably can no longer run most of the managed code reliably.
There's a problem with that as well because the background threads may still be running while we're calling this event or while we're calling the safe handle finalizers. And we can't block or abort the threads and then run user code because the whole system is in an undefined state.
Well, what I would say is, as you're running the application level code, the background thread should continue to run. Mm-hmm. And then when you say, okay, now this is the end of the process, you do what you do today, you hold all the threads, and then the only thing you do is you clean up the safe handles because whoever implements them, they're responsible for not doing arbitrary things. They should only really do close handle and whatever, right? I agree with you that it's still open-ended and arbitrary user code, but it's if you derive from this type and we tell you the only thing you should really do is close the handle, do nothing else.
Well, the problem with all the threads, it's a concept we have been running away in the runtime. So it's just problematic, right? That's why we can't kill thread abort exception in .NET Core, right? .NET, the Red Hook runtime doesn't have it, right? So if we were to kind of build this thing for .NET Native, hold the threads, it's not that. So we consider it super ugly, unreliable runtime feature, right?
But then I don't understand the pushback. Are we saying we should hold the threads, or are we saying we should not hold?
Should not.
Okay, then let's not do it then. The question is what's the downside then if we don't hold the threads?
There's stuff still around, right?
True, but at that point,
you could be creating new objects that may not run the finalizer code. There may be a point after which.
But I would consider that to be problem for the application, right? If you have background threads creating sockets, in a loop, and the shutdown code can take a snapshot. Okay, I will close these for you. But if you create more, sorry, you're off.
So what's the guidance then? If you basically have a long-running background thread, I guess you should query for how shutdown started and stop doing work essentially.
Yeah, if you have I don't know how environment.exit works with the out of band shutdown stuff, but if your application has a clear shutdown path, it should close all of its background work, wait for it to finish, and then shut down, ideally.
That makes sense for the app. I was thinking how we do it at the library layer, but I guess you would have some outer.
No, the problem is that what people like to do, they try to spam these tasks. Okay, do this background thing, right? I just want to finish it sometime in the background. The problem is while these things are scheduled, right, the application might decide shutdown, right? Then they might be like running. Nobody's like holding handle on the task, right? It's just like this void task that just like go around, I don't want to hear about you anymore, right?
But if they do that, they should be okay with that never running.
Yeah, but the problem is like if it's running while the shutdown is going on.
I honestly, I think if somebody writes code that is, the leaf code.
Actually, I have to
I don't
run.
worry about this. The only thing that I would like to really understand is, let's say we write a library that opens a listening socket. How would we write this library such that it reliably closes the socket when we shut down? But then basically somebody else hooks up to this event handler, and then we execute their code first, and they crash the
But
process.
that's no different if somebody crashes the process mid-flight.
Not-
If somebody
but not
crashes
with
the
critical finalizers. They
no,
don't-
if somebody crashes the process mid-flight, then the finalizers won't execute either. So basically, unhandled exception, like when there is unhandled exception, you are done. Like,
Unhandled exceptions, we don't run critical
No.
finalizers?
unhandled exception, you are done. Like there's nothing going anymore. Doesn't matter what they have. Unhandled exceptions are taken.
So we're over time now. Like, I think, let's just write up what we just said. It seems like should we do another round of that, or do we think we have enough information? Because I'm honestly still confused, like what the best course of action is at this point. Like, are we saying we basically start with a simple plan and add more complexity as we go, and we start with let's not run any finalization on shutdown and see where it takes us? Or are we saying, well, let's introduce some complexity somewhere, either in the runtime on our side? Because I would be quite hesitant to do that without actually knowing whether people really care that much on .NET Core.
I think the two issues are kind of linked. We can't not run finalizers and not get the motivator to run code on shutdown.
Well, yeah, I would assume we would still do the event. The question is whether we would provide a general purpose infrastructure, like, make sure safe finals run all the time, for example, like whether we would do that. I mean, yes, you could always run your own code, but I think generally speaking, that's more for apps, not for, unless library authors would do the same thing we would do, that would probably not cause any code running.
By the way, I'm fine with just starting with the simple event. And then, if we discover an issue, we think about doing something else.
And
I mean, one thing that, and it's up to you guys. Like, I don't like event handlers. I don't like events.
Yeah,
Because
that's
of the chain, it has so many issues. It's again, up to you, you decide. I would just do a slightly different. I would not use an event. I would do providers, basically a library that wants some code executed when a domain shuts down, passes a provider, and then we have more flexibility in the future how we execute the providers. Versus we have a chain of, the event handlers, and then,
and what is kind of the provider? Is it like
Yeah,
how is the provider different from
action,
event?
action of not even T.
Yeah, but you add it to a list, and for each list, and you call the code. I mean, that's essentially what an event does.
Well, except for event, we kind of cannot change the behavior.
Of course you can. I mean, you can literally ask for each handler and write your own for each loop. I mean, you don't have to just call the entire thing and let the underlying delegate do it. I mean, essentially, it's equivalent in that sense.
Theoretically.
The providers are available if you kind of want to attach extra kind of properties to the event that says hey
Oh, guys, I really have to run to another meeting now, so let me just